Hello, and thank you for joining us here today. We're going to have a roundtable discussion today on solar inverters. I'll be your moderator today. My name is Bill Brooks with Brooks Engineering. I've been working in this field of solar photovoltaics for about 23 years, and we have a distinguished panel of inverter and optimizer panelists that we're going to discuss a little bit about the issues and hopefully provide you with some background about this technology and what makes it work.
Thanks, Bill. I'm Bates Marshall with SMA America. SMA America is a subsidiary of SMA Solar Technology out of Germany. SMA is a publicly traded company in Germany on the Frankfurt Stock Exchange. SMA is the largest inverter company in the world by far. So in a relatively crowded market with 170 suppliers, we have about 40% market share, plus or minus. Here in the U.S., we have over 400 employees. We also manufacture our products here in the U.S. as well as a plant in Ontario.
Great.
Hey, my name is Mike Tobin. I'm with Schneider Electric, and Schneider is a global specialist in energy management. We produce products and design products to connect from the utility to the home. My specific job is the Vice President of Engineering and Renewable Energies business, which focuses on photovoltaic inverters. Schneider Electric is 120,000 people, about a 20 billion euro company. We're on the French Stock Exchange.
My name is Bill Rossi. I run marketing for Enphase Energy. My background is really in technology. Prior to Enphase, I worked at Google for 3 years, and then prior to Google, I worked at Cisco for almost 10 years, and so that technology heritage is really involved in the company as well. Enphase Energy was a technology company that was started in 2006. We make a product called the microinverter, so probably a relatively new inverter company on the block, and sell primarily today in the US, but expanding into Europe very soon.
Great.
I'm Clinton Porter, Director of Marketing for Kaco Energy in the United States. Kaco is one of the world's largest manufacturers of photovoltaic inverters, following behind SMA. Here in the United States, we also are producing inverters out of San Jose and most recently in London, Ontario. The company produces photovoltaic grid-tied inverters for the North American market. Our portfolio for the European markets and Asian markets include off-grid and fuel cell inverters, power conditioning devices of all types. So we're excited today to be able to represent some of those technologies for the viewers.
Great, thanks.
Jeff.
I'm Jeff Krissa. I'm with Tigo Energy, which is a 4-year-old company based in the South Bay in Los Gatos, California. Unlike the rest of my colleagues, we are not an inverter company, but make a small electronic footprint that actually integrates with the photovoltaic module that enhances a lot of the work that the inverter does in the balance of system, and we'll talk more about that. We're a 70-person company. We, as I said, are headquartered here, but have a R&D facility in Tel Aviv, Israel, and have commercialized the product about a year ago, and are continually ramping volumes throughout the world.
So Enphase Energy we make a product called the microinverter. So it's a small inverter, and it's typically utilized today for residential applications or small commercial applications. So that can range, typical residential might be smaller than 10 kW, which would be 25 or 30 panels. A small commercial installation might be as high as 100 kW, so it could be 200 to 300 panels. The microinverter is probably one of the newer technologies on the scene, and the main difference between a microinverter and a traditional central inverter is that we're converting energy at the individual panel itself instead of at the individual string. The advantage of that approach is you tend to get more energy out of each panel when you're converting at the individual panel versus the string. The other benefit is that the technology incorporates communication directly in the microinverter, so the system owner or the installer can actually visualize the amount of energy being produced from the solar array. So if there's any issue with the array, bad module, or could be some people just like to visualize the energy being produced on a sunny day. So you get that via standard mobile handset with a browser or a PC. I think the solar installers like the product because it's relatively easy to install because it's all AC.
Schneider, you have quite a variety of products, so tell us a little bit about
Okay. Unlike the microinverter, we make typically for residential applications is a string inverter. So rather than having an inverter at each module, we have one inverter down at really at your electrical distribution panel within your house. And all of the solar panels will be connected down to that one inverter. That's string for residential. We also have what we call central inverters for bigger applications such as commercial rooftops. So these are systems first in the residential were typically 2 through 6 kilowatt type of sizes. As we go into commercial rooftops, we rise to 30 kilowatt, 100 kilowatt, up to 500 kilowatt machines that are 3-phase rather than single phase. One thing's a little bit different regarding most inverters that we look at, and maybe not everybody understands in the market in residential, is that when we have a solar inverter, if the utility power goes down, we lose our power even though the sun's shining, because our inverters, the grid tie inverters, don't do any type of voltage control. So if the utility goes down, we immediately have to turn ourselves off. So that's the typical application for grid tie inverters. We also have some other systems that are called backup power, as well as off-grid. So some off-grid, if you have an island or some cabin in the woods, we can give you a product that allows you to tie the solar your solar modules down to your house to connect that one and give yourself power there. On the backup power, we have the same type of system, but on a bigger scale, running from 2 to 6 kilowatts that allow you to connect the solar panels plus any type of wind applications or wind turbines into a DC bus and then into our Xantrex XW inverter and then back out to the grid. So those type of systems allow you to maintain power even if the utility goes down. So I think that's kind of the main differences between the grid tie and backup power type of systems that we have, the residential to the more commercial sizes.
Kaco is very similar to Schneider in that context. We manufacture grid-tied photovoltaic inverters from 1.5 to a megawatt station, which we're also involved with single-phase for residential applications up to now 8 kW and into 30, 50, 100, 500.
Well, SMA is the largest photovoltaic inverter manufacturer in the world, for sure. And you have quite a variety of products. Tell us a little bit about the breadth of products and maybe what you're looking at even in the near future.
Yeah, so I think SMA is unique amongst inverter manufacturers in that we have a range of products that range from central inverters, string inverters, all the way down to our forthcoming microinverter product. So we cover all power ranges, all module technologies, and we're active in all markets worldwide. I would say our product strategy is informed by the key issue in PV of our time, which is the economics. Anybody who looks at solar, even from time to time, understands that solar has a cost issue. It is a market, a technology that's supported by government incentives in every active market in the world. So I think those of us who pay attention to the incentive programs realize that these incentive programs will not be there forever, especially in these economic times and the budget crunches worldwide. So we are singularly focused on cost reduction through the development of system technology. So if you look at the 30-year history of our company, what you see is that we have a track record of year-over-year system cost reductions. And this is a key point because we're not just focused on slashing the price of the inverter year over year like you might see happening in the module world, but actually technological innovation that would drive the entire system cost down. So that's our strategy, is to lead with technology, but technology focused specifically on system cost reduction.
I think initially for microinverters, they were used to overcome issues on the roof. It could be shade from a tree or a chimney or a telephone pole. So oftentimes, to get the most energy out of the system, you needed to have that individual PV module inversion. I think as the industry has developed, that tends to be less the case now. I think more and more we're seeing microinverters going into standard situations with little or no shade. I think the factors that are driving that, I think, are two things. One, the reliability. They don't suffer from a single point of failure. You have multiple microinverters on a roof. So if any one microinverter were to fail, the system is still running at 98 or 99% availability. So that's probably the primary reason. I think the secondary reason is the visibility that they get because the communications and networking is built directly into the microinverter. The installer or the system owner can see what's going on a real-time basis. So if anything were to happen with the array, they could address it very, very quickly. Oftentimes, I think with string or central inverters, although they have monitoring, lots of residential and small commercial system owners don't end up deploying it. So oftentimes, if you have an issue, it can go unrecognized for days, weeks, at least until you get your next utility bill.
Yeah, I would just jump in, Bill, and say that the answer really varies by segment. And even though at the end of the day, PV is all about maximizing energy at the lowest cost, the way those specific math works out is quite different if you're an individual homeowner with a single-family home or if you are a utility-scale developer building a ground mount plant in the desert. So the issues of performance and cost are always there. Even within that segmentation, SMA has at least a couple of different architectures or topologies to offer, and then the variation really comes down to what's the customer's business model and how do they intend to go forward with the project, how is it going to be financed, but everything is always in mind with energy generation and keeping it down the initial price, but also the ongoing operations and maintenance pricing.
I think as you're pointing out, Bates, about the system cost being the most important thing, and if my understanding on the microinverters, typically it's a more expensive, it has some other features, but it's a typically more expensive installation. So from a central or string inverter, it gives us the ability to have everything at one spot. It's a lower cost, but even for a system reliability, there's things of where you have to have multiple inverters on a rooftop for the microinverter versus one point of failure on a string inverter combination.
Well, I think it's important also to mention that the type of incentive that's being delivered to the consumer is important when factoring the cost of the energy. Obviously, if it's a performance-based incentive where kilowatt-hour performance is of utmost importance, it's going to be a different situation than if they're receiving an upfront incentive.
Our view is that the microinverter has brought some very, very nice features and light to some very nice features. But those features being offered to the homeowner are equally, we believe they're equally as important to somebody running a multi-megawatt station. You still want to make sure your assets are functioning. You still want to make sure they're safe and producing the most energy possible. That's not something that should be reserved for a 4 kilowatt residential application. Although right now the cost dynamics of it tend to slot it towards smaller installations.
Well, there's interest, Bill. You were saying how the inverter has been around for about 50 years or so, but it's really a new application of the inverter. As we look at today with our inverter, they're continuing to change. So right now you could say you'd rather have the micro or the string inverter, but as we move along, we're trying to figure out better ways from a system, how to create systems, how to make them safer, more efficient, and really all the groups are working together with UL and standards to try to understand that. So we're gonna, as we look at today, things are going to be changing even tomorrow and next year.
Enphase is taking a huge part of the market segment of the residential market in the United States. How does that happen? How did that happen? You've only been a company for how many years, and now you're knocking on the door of being the #2 supplier in the United States.
Yeah, the company was started in 2006. So 2006, 2 years later, started shipping products. So in 2008 was when we first shipped our first microinverter, and roughly 2.5 to 3 years later, we're well over 500,000, approaching 750,000 microinverters with about 20% of the market in California, which puts us probably a clear #2. I think in the U.S. market, especially in California, installers I think are generally open to new technologies, and so it was a great place for us to kind of plant our roots. And I think just the microinverter value proposition, right? The fact that it can deliver more energy, so it will come at a higher upfront cost. It tends to be anywhere from 20 to 40% in terms of, if you look at just the pure inverter price. But the inverter only represents about 10% of the overall system cost. So on a system basis, the actual cost increase isn't that dramatic, and the fact that it's pulling out 5 to 10% more energy usually justifies the upfront cost. So, the installer has to make that pitch to the system owner.
Sure.
System owner has to be willing to say, I'll sacrifice some of my upfront dollars, knowing that I'm going to get more energy over the long run. So I think that has been the real strength of our offering, the fact that we get more energy and we can do the monitoring.
Let's talk about cost for a minute, because Bates brought that up, and I think it's a great point. Now, obviously, cost ultimately, at the end of the day, is what matters.
I would have to say something like $1 per kilowatt hour metric, which would take into account both the acquisition price as well as the long-term service and maintenance costs, as well as the energy production. There are those who lean on LCOE, levelized cost of energy, but typically those types of analyses take into account things which are significantly out of an inverter company's scope of supply, like the cost of land and the cost of capital. So we would typically lean on $1 per kilowatt or megawatt hour.
So energy, how much it costs for the energy.
Well, I think I still have along the same lines. We have to look at the dollars per watt, but the target has to be towards the grid parity, as we say. So it's where it doesn't need any external or government funding. So that's the driver, is what cost do we have to get to where we don't require any government funding anywhere in the world. And so that's kind of the target, because that's where the wind industry is kind of really already there, but they got there through a lot of government funding. So we still need that government funding to help us get there. From an overall system cost, there's a lot of different components within there. With Schneider Electric, we're working across the whole gamut. So from the switches, so the DC switches, across the inverter, across all the connection points. We're working all those areas trying to bring the cost down.
I would agree, dollars per watt. I think the challenge in residential installations is, the customer tends to be very focused on the upfront cost of the system, because they don't know, sometimes they don't know if they're going to be in their house 5, 10, or 20 years. So we try to get them focused on the overall cost of the energy being produced, the value of the energy being produced. That's more effective, I think, in commercial installations where they understand that.
Right.
Residential, it's been, for us anyway, it's been an education process.
Sure.
I think, Bates, you said something interesting too, $1 per kilowatt hour, which is something we talk a lot about, because most of the installers that we'll talk to, or project developers, will reference that dollar per watt number.
Yes.
When in the background of coming from a tariff environment where folks are receiving payments per kilowatt hour, they really do look at how much energy is produced by their system rather than how much the upfront capital costs are. And so that difference between dollar per watt and dollar per kilowatt hour is interesting. I think that I'd like to see it move towards a dollar per kilowatt hour conversation, because we can talk more about how much energy you're actually producing, and the commodity you're providing, electricity, is maximized. But that being said, the reality on the ground still seems to be that most folks will talk to us, and what we focus on is reducing that dollar per watt number. So that
Yeah, I'm sorry, I didn't mean to cut you
No,
off,
it's
but
fine.
I would just add that I think again, the economic considerations to me are near the top of the list, because if this was an era of easier credit, your average homeowner, your average commercial enterprise could easily go out to the bank and get bank financing for something that's going to pay off on a 30-year term. The reason there's such a focus on acquisition price is because for the residential market, these people are writing big checks or otherwise having to finance these systems themselves.
bottom line for folks was, well, how much does it cost? That's all they really wanted to know. When it came to reliability and features and monitoring and all the other stuff that we care about as educated solar people, they didn't care about that as much. They really wanted to know how much it cost.
In the end, it's that cost of ownership.
Right. How much does the check need to be?
If you could tie that cost of ownership over the years, we're going to talk about warranty also, but how long is that system going to last? If that system's only going to last 5 years or 10 years, then you got a problem you're going to get back and replace. So your time value of money, your net present value, is hurt. If the product's going to last for 15, 20 years, or it's easy to service, those are things that help to reduce the overall cost of ownership. We have commercial customers that require to have 20-year service contracts, so they can look at that cost right now. So there we look at the parts that have to be replaced at the intervals of 5-year, 10-year, or 20-year to make those products last that long.
Well, I guess that's the answer to your question, though, is I still find it to be, across the spectrum of the North American market, to be dollar per watt for us, and really reducing that as the most important consideration for us currently, with an eye on that dollar per kilowatt hour number.
There's just no departing from the CapEx equation, right? Because even when you can sell reduced kilowatt hours, there's still the homeowner, for example, is getting 4 bids and will generally choose the lowest bid. So, being able to have a cost-effective roadmap I mean, we're in an environment where we're looking at the balance of system, but perhaps the larger chunk of the cost is actually in the photovoltaic material, which is dropping like a rock.
Mm-hmm. So I'd say we look at purchasing a warranty, the important thing is that at the end of 10 years, your company's still around. So one for Schneider Electric, we've been around for 175 years or so. So we got a good chance of being here in another 10 years. So that's probably the most important thing, is that we'll still be here and that company stands behind it as we do. For us, we don't want to pay warranty, so we want to make sure that the products last for those 10 years. So a lot of things we brought first, our company from Schneider Electric, we had purchased a company called Xantrex, and that was purchased in the end of 2008. So Xantrex had lots of experience in photovoltaic world. Schneider has lots of experience, one of the biggest inverter manufacturers in the world, from the APC and from the drives manufacturer. So what we do is we take all the experience we have within Schneider and try to apply certain design standards to say, this is how you're supposed to design an inverter to last for this many years. So the things we try to do to that during the development cycle is put it through some really robust testing. So extreme temperature, cycling testing, putting in through a test we call MEOS, where we go into vibration, humidity, voltage cycling, all these things at the same time. So the whole important thing is that we cycle those inverters as hard as we can to find the weak points within the inverter so we can fix them now. And on top of that, so that's kind of in the development process. So we take all those learnings during the development, fix the inverter, so our best bet is that inverter is going to last during the whole time.
You know, similar to that, warranty as the financial instrument,
Right.
there are things small companies do to make sure we have the right venture backing and the right insurance and the right, aspects of the financial coverage. So that we obviously do, and I would imagine most companies our size do. What you really look at when you're taking a gamble on new technologies, you look at worst case scenarios and the downside and the worst case scenarios. The worst case scenario is any one of us are gone in 5 years and the investor's left holding the bag. And again, that's one of the advantages of the topology that we represent, is the investor is still working with SMA, Kaco, Schneider, somebody that they've trusted for years, they understand and they know, and augmenting that solution with Tigo. If, God forbid, we're not here in 5 years, the topology is exactly the same. They turn us off in software or they reroute the cabling, nothing changes. The topology is exactly the way it would have been ordinarily. So the downside risk is very, very low anyway. But clearly that's not our intention. Clearly we believe we'll be here for many years to come, and we've architected a minimalistic, solid product that's warranted towards, since it's on the panel, it's actually warranted to 20 years because the expectation is that it's matched to the panel.
Bill, can I just make a point about quality and warranty
Sure.
in a different segment? We've
Sure.
been focused, I think, in the answers to this question on the residential segment. But if you switch gears to maybe talk about the utility segment, talking about very large ground mount projects, we have customers who are developing multi-billion-dollar projects. So when you're talking about warranty and quality on projects of that scale, the due diligence that is involved, typically shorthanded as bankability, is extreme. So these are banks and other financing entities that are putting potential suppliers through an incredible gauntlet, and so the factors that come into play in that kind of due diligence, are orders of magnitude larger than what an average homeowner is doing when he is making this very significant but $10,000, $20,000, $30,000 buying decision. So when we look at bankability on utility scale projects, we've been asked to do things like provide all sorts of financial metrics, cash flow, capital to debt ratios, and other key metrics. And because it's again one of our strengths, because of our financial transparency, that's all there for customers to see. So I just wanted to make the point that at the other end of the spectrum, those same issues of quality and warranty are in effect. Only the risks, the ramifications of a bad decision are much higher.
And in 30 seconds, what information would you like to get across from your company and the values of your company that would make them want to decide to purchase your product?
Yeah, the summary is always tough, but I would just say that I'm more than anything else at SMA, all of my colleagues share the belief that we are proponents of the industry and big fans of helping everybody succeed, because if any one of us at this table gets a black eye, it's a black eye for the industry at the end of the day. I think that the key message for the average homeowner or the average business owner is that with the current suite of incentives in play today, we are essentially at grid parity. So the decision of whether to proceed with the PV system or not is simply a financing decision. There are all sorts of innovative business models. Our customers are bringing them to the market every day, from the residential scale to the commercial scale. And I think what we've found, at least in our experience, is that unlike the consumer world of electronics and gadgets, what pays at the end of the day in PV is old reliable. People like old reliable. It's kind of like the airline pilot. He's most comfortable with old reliable. So that's why customers use us.
Mike, what do you say?
Hey, well, for Schneider Electric, Square D, APC, those name brands bring home to all of our customers high quality. So we are determined to maintain that reputation for high quality. We plan to completely stay focused for our group within renewable energies business, and it's really from those modules out to where it goes back on the utility. So our customers, whether they're residential, commercial, or the utility guys, we're going to be in those systems and on there supporting them for the remainder of time.
Bill?
So I would say most of our customers today, a good majority are homeowners or residential, and there it's all about like put something on your roof that's going to give you the most amount of energy and last the longest amount of time, and you can monitor it, right? You can see it. So that's primarily our pitch.
I concur. I think at Kaco we want folks to understand that they need to take a moment to investigate the company that they're going to choose when they pick an inverter, and it's important to make certain that the company they choose has a history they can rely on, has a product that they want to have hanging on the side of their house for the next 20 years, and that will be backed up by the strength of the team that supports it. I think that's one of the most important considerations when you're buying a system that's supposed to be on your roof for 25 years.
Jeff?
So I agree with Bates. There's no other investment that I can think of that has double-digit returns the way solar does in most states in the U.S. with the safety and security that the investment would have. It's an amazing way to put money to use, and I think the consumer across the United States should really look at that as a way to do good by the environment, but also a great investment. And when they make that investment, we would encourage them to add the little Tigo on the module, just so they can see the value of that investment over the next 25 years and make sure that it's working well for the whole time.
Great. Well, thanks everybody. Appreciate the panelists taking their time, and hopefully this has been valuable for the people watching. They learned a lot today, and hopefully you'll go into a buying decision with a lot more information. Thanks, and have a great day.
Thanks, Bill.
Thanks, Bill.
Thanks.